Good afternoon, everybody. I am Mahendra Kumar, Senior Lecturer, Civil Engineering from Government Polytechnic College, Batala. Today, I shall discuss with you very important topic of leveling from the subject of surveying 1 of 3rd semester civil engineering. So, leveling is a very important or very vital for an engineer. So, you have studied the definition of surveying, whereas leveling is the branch of surveying which deals with the measurements in the vertical direction. In surveying, we take measurements both in horizontal as well as in vertical directions, but in leveling we take measurements only in the vertical direction. So, leveling is the art of finding the relative heights and depths of the objects on the surface of earth. It deals with the measurement in the vertical plane, as I have said earlier. So, leveling is of prime importance to an engineer for the purposes of planning, designing and executing the various engineering projects such as roads, railways, canals, dams, water supply and sanitary scheme, etc., or maybe any projects. So, leveling is of great importance to an engineer. So, what is the principle of leveling? Principle of leveling lies in furnishing a horizontal line of sight and finding vertical distances of the points above or below the line. This is done with the help of a level and a leveling staff, which we are just going to study. So, principle of the leveling lies in furnishing a horizontal line of sight, which is achieved with the help of a leveling tube. So, principle of leveling lies in furnishing a horizontal line of sight and finding vertical distances of the points above or below the line. This is done with the help of a level and a leveling staff. So, what is the level? Level generally consists essentially, that means a level consists essentially of a telescope and a level tube to provide a horizontal line of sight, which is the principle of leveling, fitted above the leveling head. So, every level consists a level tube and a telescope for furnishing a horizontal line of sight. A level is supported on the tripod stand, that is a stand having 3 legs, which is called as tripod stand when it is in use. So, level is supported on the tripod stand. So, following are some of the important parts of the level. First is leveling head, second is telescope, eyepiece, diaphragm screws, focusing screw, ray shade which is used in case sun is shining, a level tube is there, a level tube nuts are there, cross bubble tube is there. There are 2 tubes, one is long bubble tube and another is cross bubble tubes. So, in a level generally we find these essential parts on or over the level. So, as on your meter screen, all these parts which I have just told to you, these are labeled on the diagram of a general level. So, you please see on your meter screen the parts of a level. So, on this side this is eyepiece, this is focusing screw, this is object glass, these are foot screws. So, this is long bubble tube, here we find cross bubble tube. So, level is there, level tube is there, leveling head is there, leveling screws are there, foot plate is this. So, this is the telescope of the level, this is the foot plate which we fit generally on the tripod stand. So, this is the overview of a level. simple level and various parts are labeled on the level. So, kinds of level, generally we have 5 type of traditional levels. First is Dumpy level, second is Y level because it has a shape of English alphabet of Y type. Cooke's reversible level was invented by an scientist Cooke's, and similarly the Cushing's level was also invented by a scientist Cushing's, and India's contribution is also there, and Indian level is generally known as IOP level, modern tilting level or Indian office pattern level. So, these are the traditional 5 type of level we generally find in our book, and there are lots of other level which have come up with the invent of science and technology. So, we find various types of levels such as auto level is there, quick setting levels are there, but in the books we generally find these 5 types of level. So, out of these 5, this Dumpy level is one of the most important and mostly used in our most of the projects, and in the field the Dumpy level is mostly used. So, what is Dumpy level? A Dumpy level is an optical instrument used to establish or check points in the same horizontal plane. What is this? A Dumpy level is an optical instrument used. Optical instrument means there are lenses provided in the telescope. So, Dumpy level is an optical instrument used to establish or check points in the same horizontal plane. It is used in surveying and building to transfer, measure or set horizontal level. So, Dumpy level is generally used to transfer, measure or set horizontal levels, that is it is generally used for leveling works. So, on your meter screen a person is using the Dumpy level instrument. So, please see on your meter screen a Dumpy level is fitted over the tripod stand, that is the stand having 3 legs. So, person is seeing through the eyepiece of the telescope or the Dumpy level, and a person is using. So, this is a good view how a Dumpy level can be used in the field. A person is using the Dumpy level in the field. So, through this level we generally see the leveling staff. So, a person is also holding a leveling staff, that is generally it is a scale. Graduations are marked on a vertical target. So, which is called as leveling staff. So, please see on your meter screen a person holding the leveling staff. So, what is Dumpy level? It has the vertical spindle and the telescope barrel cast in one piece, and therefore, it is termed as solid Dumpy, and that is why it is called as Dumpy level. So, Dumpy level is simple, compact and stable. Dumpy level is simple, compact and stable. The telescope being rigidly fixed to the supports can neither be rotated about its longitudinal axis, nor it can be removed from supports and changed end for end. It has greater stability of adjustment than the Y level, but its permanent adjustment involves long procedure and takes much time and is necessarily done outdoors. It is generally used for field works, as I have said earlier. So, Dumpy level is mostly used in the field works. So, there is leveling staff. I have just told you this is a graduated rod over which graduations are inscribed over it, and it is used for measuring the vertical distances of the points above or below the horizontal line of sight. So, this is called as leveling staff. Leveling staffs are divided into 2 classes, that is there are 2 types of leveling staffs. First is self reading staffs and second type of class is target staff, self reading staffs and target staffs. The former are so called, that is self reading staffs are so called as they can be read directly by the level man, that is the person using level, through the telescope, while the latter, that is the target staffs, are provided with a movable target. The target is equipped with the vernier which is adjusted by the staff man as directed by the level man until the center line coincides with the horizontal crosshair of the diagram. So, these are two types of staffs. First is self reading staffs and second is target staff. The reading is then taken and recorded by the staff man, that is the person holding the staff is known as staff man and the person using the level is called as level man. Target staffs are used when the sights are too long, that is when the sights are more than 100 meter long, then we use target staffs. Their use is rare in Indian area. So, self reading staffs, these were previously marked in feet, tenths and hundreds, but nowadays they are marked in metric units such as meters, decimeters, etc. In the PWD offices, we still find leveling staffs graduations in the feet or FPS system, but in our education institute or most of the departments they have this metric units graduations inscribed on the telescopes. So, these, that is staffs, are several types of there are several types of leveling staffs available, but only few important are of following types. So, first one is soap with telescopic staff, that is it is just of the shape of the telescope. Second is folding staff, third is one length staff and fourth one is invar precision staff. So, we will study one by one. First is soap with telescopic staff. You just have picture of the staff on your right side of the monitor screen. What is the soap with telescope staff? It is commonly used type of leveling staff. It is usually arranged in 3 telescopic lengths and is 4 meter long, that is its length is 4 meter when we fully extend, that is when this staff is fully extended its length becomes 4 meter long. The solid types top length is 1.25 meters which slides into the central box of 1.25 meter long, while again slides into the bottom box of 1.5 meter length, that is there are 3 lengths of 2 of 1.25 meter each and the third one is 1.5 meter length. Each length is held in extended position by a brass spring catch. Sorry. Carelessness in extending the parts to full length may spoil or may harm the whole work. So, care should be taken while extending this type of staff, that is the telescopic type staff should be extended very carefully. So, the smallest division marked on the telescope staff is 5 millimeter on every leveling staff. Smallest division will be of 5 mm thickness, that is in the metric unit it will become of 0.005 meter dimensions. The metric numerals are on the left and are marked in the red ink, but the numerals are on the decimeter numerals are on the right side and they are in the black color, that is on the left side you find metric numerals marked in red and on right side there are decimeter numerals, they are in black color. The graduations are marked in erect and are seen inverted when viewed through the telescope. This is most important. Please note down that when we see through our levels which we have in our institutes, when we see through them, we find the image inverted, that is upside down. So, but nowadays these levels have been corrected by incorporating another lens into the telescope, so that the graduations become erect, but in the levels which we have in our institutes, we find the image inverted. So, this is of more importance. So, second is folding metric staff. The Indian Standard Institution ISI has discarded the telescopic type leveling staff, which is very important. That is, ISI has discarded the telescope type leveling staff and has adopted the folding type, because it is lighter, more convenient to handle and gives more accurate readings. That is, there is one joint in the center. So, its length is also 4 meter, but a joint in the center. So, there are two parts of 2 meter each. So, it is made of well seasoned timber such as deodar, blue pine or cypress. It is 75 mm wide, 18 mm thick and 4 meter long. As I have said earlier, the length of folding metric staff is also 4 meter when it is opened, and it is arranged in two lengths, each being of 2 meter length and connected at the middle by an hinge. So, you must have seen in your labs the folding type of leveling staff. The folding type of staff is not detachable type, which a locking, it is of a detachable type with a locking device at the back. That is, we can detach it. It is joined together in such a way that it can be folded to a 2 meter length, so that it can carry to the site of the work. The two pieces can be detached from each other when required to facilitate easy handling and using one piece, and when two portions are locked together, the two pieces become rigid and straight. It is provided with a circular bubble of 25 minutes sensitivity fitted at the back and two folding handles. So, each meter length is divided into 200 division, each being 5 millimeter thick. Space indicating the decimeter readings are marked in red, while all other spaces are marked in black against a white black ground. Each decimeter length is figured with the corresponding numerals in black and marked to the left. The meter numerals are marked to the right in red. The graduations are inverted as in the previous staff also, because it is viewed in the level, so that when seen through the telescope they appear erect. So, third type is one length staff. It is usually 3 meter long in one solid length and is graduated to 5 mm in the same way as other staffs. It is used for precise leveling work, that is, when accuracy is required, we can use one length staff. And fourth one is invar precision staff. It is usually 3 meter long, and invar band graduated to a millimeter is fitted to a wooden staff tightly fastened at the lower end by a spring at the upper end. Thus, any extension of the staff has no effect on the invar band, and this staff is used for most precise leveling work. So, now we have important terms used in the leveling chapter. First one is level surface. This is a surface parallel to the mean spheroidal surface of the earth. For example, the surface of still water in lake. Every point on this surface is equidistant from the center of the earth. It is normal to the plumb line at all points. Any line lying in the level surface is known as a level line. So, next is horizontal surface. A horizontal surface through any point is a surface tangential to surface at that point. It is perpendicular to the plumb line any line lying on this surface is called as horizontal line. Third one is vertical surface. A vertical surface through any point is surface normally to the level surface at that point. Any line lying in the vertical surface is called as a vertical line. It is normal to the level line. Next is datum surface or datum line, which is very important. It is an imaginary line, imaginary level surface or a line from which vertical distances of the points above or below this line are measured. So, in India, the datum adopted for GTS or Great Trigonometrical Survey of India, which is in the Dehradun, mean sea level at Karachi is taken as 00 or datum surface. Next is reduced level. Reduced level of any point is the height or depth of that point above or below any datum. It is also known as elevation of the point, which is very important. The elevation is positive or negative accordingly as point is lying above or below the datum. A station. So, this is very important. Any point where the leveling staff is held and the reading taken during the process of leveling, this is called as station. It may be noted that it is a point where the staff is held and not a point where the level is set up. This is very important. So, please note down, it is a point where staff is held and not the level. So, now we have line of collimation or line of sight. It is an imaginary line joining the intersection of crosshairs at diaphragm to the optical center of the object glass and its continuation. Please see on your monitor screen. So, this is the line, imaginary line joining the intersection of crosshairs at diaphragm, this place, to the optical center of the object glass and its continuation. This is called as line of collimation or line of sight. Next is axis of telescope. It is an imaginary line joining the center of eyepiece and the optical center of the object glass, as is on your meter screen, axis of the telescope. So, this is again very important definition, backside reading. It is the staff reading taken on a point of known RL as on a benchmark or on a change point. It is the first staff reading taken after the level is set up and level. It is positive. Foresight. It is staff reading taken on a point whose RL is to be determined, that is, whose RL is to be found out. It is the last staff reading before the instrument is taken to another position. This is called as foresight reading. Next is intermediate sight reading. It is any reading other than the foresight and backside taken on a point of unknown RL from the same setup of level. All readings taken between the backside and foresights, they are called as intersight reading. In one setting of level, there is only one back and one foresight, but there can be a number of intermediate sight readings. So, height of instrument, it is the RL of the line of collimation. When the instrument is correctly level, the height of instrument does not mean the height of center of the telescope above the ground where the level is set up. Change point, it is an intermediate staff station on which two sides, foresight and backsides, are taken and is used for the purpose of changing the position of the instrument. This is very important. This is a point where two readings are taken, that is backside and foresight, and it is used for purpose of changing the position of the instrument and called as change point. Next is benchmark. It is a fixed reference point of known RL which is called as benchmark, and benchmarks may be classified as GTS benchmarks, permanent benchmarks, arbitrary benchmarks and temporary benchmarks. So, these are the classification of various types of benchmarks, and we have adjustment of the Dumpy level. It has two type of adjustment. One is temporary adjustment, which is done at the every setup of the level, and another is permanent type of adjustment, which we do which is done by the skilled person we cannot or when we will be skilled person, then we can do that permanent adjustment, but temporary adjustment is made after every setup of the level. So, these are performed to make the axis of the rotation vertical and to eliminate the parallax every time when the instrument is shifted and set up in a new position. It is also known as setting up of the instrument and is made in the following steps. First step is fixing the instrument on the stand, second is leveling up of the instrument, and third is focusing. So, these temporary adjustment is done in these 3 steps. So, we will do one by one. First is fixing the instrument on the stand. So, release the clamp screw of the instrument, hold it in the right hand and fix it on the tripod stand by turning round only the lower part with the left hand, then screw the instrument firmly. So, this is the fixing the instrument on the stand. Second part is leveling up of the instrument, and it is done approximately by legs and correctly by leveling screw, but a lot of time is saved if we do the leveling firstly by legs and then by foot screws. So, first part is leveling by legs. Bring all the foot screws in the center of the run and place the instrument in a desired position at a convenient height. Fix any 2 legs firmly into the ground by pressing them with hand and turn the telescope to be nearly parallel to the line joining the feet of these 2 legs of the tripod stand. Then move the third leg to right or to the left and in or out to bring long and cross bubbles respectively in their central positions. Much time is saved if nearly all the leveling is done by the tripod legs. I have said it earlier that we save much time if nearly all the leveling is done by the tripod legs and we do not have to move the foot screws for leveling. So, leveling by foot screws. So, after doing leveling with the leveling legs, now it is the turn with the foot screws. Place the telescope parallel to the any pair of the foot screws and bring the long bubble to the center of the run by turning these screws equally, either both inwards or both outwards. To move the bubble to the right, turn the screw inward, and to move it to the left, turn the screw outwards. Please note down, to move the bubble to the right, turn the screw inwards, and to move it to the left, turn the screws outwards. That is, to remember it, we have a formula, right in and left out. This is the formula to remember. Then turn the third foot screws to bring the cross bubble to its central position. That is, we have to bring both of the bubbles to the center. Repeat this process till both the bubbles are centered. That is, in this way we center bubbles of long bubble tube and cross bubble tube exactly in the center. Focusing, third and important point is focusing. This is done. What is the purpose of focusing? First purpose is focusing the eyepiece of the level for distinct, that is very sharp vision of the crosshairs at the diaphragm. That is, we have black crosshairs at the diaphragm. For clear and sharp vision of those crosshairs, we do the focusing of eyepiece. Then focusing the object glass for bringing the image of the object into the plane of the diaphragm. That is, for clear vision of the image, we do the focusing of the object. So, first part we do, direct the telescope towards the sky or hold a piece of white paper in front of the telescope, move the eyepiece in and out until a distinct, that is very sharp or clear black image of the crosshairs is seen, then it is meant that focusing of the eyepiece has been done to find out the clear and sharp image of the crosshairs at the diaphragm. Second part is focusing the